A very good day. I'm Rinush. My part is calculate the P control of flow measurement control system. So this is the example of the control system. So we need to calculate the flow measurement of the P here. So the graph is given here and we need to calculate from the graph. So given that value Kp is equal to 1.9 and Kd equals to 0.7 and PO is equal to 35%. So first we need to calculate from 0 to 2. So the formula is m equals to y2 minus y1 over x2 minus x1. The y2 and y1 we need to take from here. 0 is x1 and y2, and the 2 second is y1 and y2. So when we substitute the value, m is we get is -2, and we need to substitute the m value to here, y equals to mt plus c. So the y is -2 and the m is -2 and t is 2 second and plus c. So C we get is 0. Then the error equation is EP equals to MT plus C. So we got is EP equals to -2. And from that value, we need to substitute the value P equals to KP EP plus P0. So KP is 1.9 and EP is -2T and PO is 35%. So we get the solution is -3.8T plus 35. So we need to substitute the T value in here because we're calculating like 0 to 2 second. So for 0 second, we get is 35%, and 2 second, we get is 27.4%, and for 1 second, we get is 31.2%. So the next is we need to calculate to, so now we calculate to 0 to 2 already. So now we need to calculate to 3 to 4. So the 3 to 4, same as just now, EP we calculate, and we need to substitute the value in the P like 1.9. EP we got is 2.5T minus 7.5 and need to substitute the value in P and then substitute the value in, we need to substitute 3 second and 4 second in T. So we get is 3 second is 35% and 4 second is 39.75%. As we see here 3 second 35% and the up there 3 second is, we get the same. So we need to follow the equation and like do the calculation. So we need to do until 15 seconds as the shown in the graph. And here are the control output for all the 15 seconds. So after that, when we generate graph in Excel form, when it got negative slope 0 to 2, the current output will decrease. When it got positive slope, the current output also increase. So that's all for controller output response for P. So the next is for PD. So for PD also we need to follow from the graph as I said just now. We need to take the x2, x1 value and y1, y2 value from here from the graph. So the given value is Kp is equal to 1.9, Kd equals to 0.7 and PO equals to 35%. So first we need to do the m reading, m equals to -2 and y equals to mt plus c. We substitute the value c equals to 0 and the array equation when we substitute EP equals to -2. Then the formula for this one is P equals to Kp EP plus Kd Kp differentiate dep over dt plus PO. So we substitute the value 1.9 is Kp, EP is equal to -2t and Kd is 0.7 and Kp is 1.9 and d over dt bracket -2t plus 35. So we get the answer is P equals to 32.3t minus 32.34 minus 3.8t. So after that, we need to substitute the value, assume t equals to 0 second, 1 second, and 2 second. So we get the answer is 32.34% for 0 second, 28.54% for 1 second, and 24.74% for 2 second. And we need to follow the step as below. So next we need to do is 2 to 3 second. Then after that, we need to substitute the value as below. then only we can find 2 second and 3 second. Then after that, follow the step below 3 to 4 second, and we need to continue until 15 second. So after that, we continue the step until 15 second. We need to do to a table so we can like easily can identify the thing. So in PD, we got like different for 2 second and 3 second, as you can see, like 4 second, 5 second, every got two values. Like for 0 is 32.34%, the controller output, and 1 second 22.54%, and 2 is 24.74%, and the second two is 32.72%. So we got until 11 like that, and after 11, continue from the 12, the percentage is same. So we got all the control output same percentage. When we compare to the graph, here also, when we got the negative slope, the controller output decrease, and we got the positive slope, the controller output decrease. So we got two value. So the each second, like from 2 to 12 second, we got two values. So that's all from my part. Thank you.
Hi everyone, I am Pugal. I will explain my part, which is PI controller for the power measurement control system. The values that are given to my group is KP equals to 1.9, KI equals to 1.1, and P0 equals to 35%. So the formula for to find the P values for the PI controller is KP multiplied by the EP plus KP multiplied by the KI multiplied by the integration of the EP plus P0. So I just have to substitute these values in the formula. And for my first part, I got EP equal to negative 2t. This EP I've taken from the previous part, which is done by substituting the gradient, which is y plus c. And for PI, the values should be same. For example, at 2 seconds, I got 19.04 percentage. And when I do the next part, for the EP equals to 40 minus 12, my T is still same, 15.04%. So, but to find the next part, we need to find the P2 value, which is done by Kp multiplied by Ki multiplied by the integration of the previous Ep, which is negative 2t, and plus the previous P value, which is 35. So I got my new P, 36.64, which will be added to the new P, which will be added to the formula. And this is my table. This is my table for the PI control for control system. With this, I have plotted the graph, and this is my graph control output response for PI in flow control system. And this is for the PID controller. In PID controller, we need to have KD values. For my group, the value is 0.7, and the formula is changed a bit. So for example, the value is still same until the integration part. After the integration part, we need to add this formula, this term, which is KD multiplied by the KP multiplied by the derivative of the EP and added by the P. So for the first part, I use the P0, which is 35%, and I have substituted the values into the formula. So I got these values as my answers. And for the next part, the values for the PID controller is not same like the PI controller. For example, for 2 seconds, I got 16.38%. So when I do the calculation for the PP equals to 40 minus 12, I got the different value, which is 8.89%. So yeah, and also we need to still find the new P values. Since I already did the P values for the PI controller, I just took them from there and added in the formula. this is the graph for the PID controller. The graph is a bit long compared to the PI controller because we have added the new term. So we for each second I get two answers. So my graph is like this. This is the graph for the controller output response for PID. That's all. Thank you.
Morning, my name is Selvendran. Today I'm going to present about level measurement control system. Here are the calculation that I do, which is for 0 to 8 seconds. So the value that we get from the both side, it's equal for the first 2 seconds, which is the 2 second value is 45.2%, and here also the for the 2 second is 45.2 percentage. And then also same for the 3 to 4 seconds and 4 to 6 seconds. So the value we get from both sides is equal. For the 4 second, we can see here 59.9% and then 29.9%. Then here we go for the 6 to 7 second and then 7 to 8 second. So we can see the values same. There are no changes. So after the 8 seconds, the percentage is maintained at a constant level. Here we see the table. So the output increase and then decrease at 3 seconds, and then it's okay again it's decrease and then it's increase at 8 seconds, and then it's increase and then it's decrease. After 8 seconds, it's maintained a constant percentage. Here we can see from the graph. And then next for the AI controller for the level measurement. So here is the calculation. So for the 0 to 2 seconds, we can see here. So the EP value that used from the previous one. Then we do for the 2 to 3 seconds. So for the so we can see for the 3 seconds, we get 53.81 percentage. The same we get it here. So the value is doesn't change. So for the 4 second also same 44.97 percentage. The same we get at here also. And then for the 5 to 6 seconds also same. 6 to 7 seconds. So for the so there are no changes at both sides. So for the 7 second, we get 50.865 percentage. And here also same. After the 8 second, it maintained at constant level, which is 51.72 percentage. So here the table. So the values increase and then decrease at 4 second, and then it's again increase at until 6 second, and it's again decrease and increase. Here we can see from the graph, it's increased at 0 to 2 seconds, and then it's decreased to 4 seconds, and then it's again increased until 6 seconds, and then it's decreased to 7 seconds, and then after the 8 seconds, it's maintained at constant percentage. That's all. Thank you.
A very good day. My name is Ephraim Simon Rajaram, and my matrix number is B0821100057. And I took the part PD and PID for level measurement. First, you can see here that the proportional gain is 1.9, the relative gain is 0.7, and the percentage without any error is 35%. Each group gets different values. This is our value for our group 2. First, we have to find from range 0 to 2. First, we find the gradient. This is the formula for gradient. M equal to y2 minus y1 over x2 minus x1. Well, for this gradient, we use the graph that was given to us. This is the graph for level measurement. As you can see that for 0 second, it's 0, 0, while at 2 seconds, it is 6, 2. No, I'm sorry, 2, 6. It's xy, so 2, 6. So we can see here 2, 6 minus 0, 0, and we can get the gradient is 3. Then you put the gradient into the formula y equal to mt plus c, and you can get the c constant. And then from these two values you can get the error equation EP, which is EP equal to mt plus c. For this situation here is 3t. Now with all these values, now since we already find EP, now we can use this formula, P equal to Kp times EP plus Kd times Kp times the derivative of the error equation plus PO. Then now we just have to substitute everything, all our values given to the values given to us and the value we found, which is EP. We have to just substitute into this, and you will get this equation, which is 5.70 plus 38.99. Since we are finding from the range 0 to 2, which is 0, 1 and 2, so we just substitute the value t, 0, 1 and 2 respectively into this equation, and so we can get that at 0 second it is 38.99%, at 1 second is 44.69%, and at 2 seconds it is 50.39 seconds. The same thing, we just have to repeat the process, just increase in range. Now this is from range 2 to 3. Now just same thing, we just use this graph, which is 2 and 3. You can see here, C3 is 3 0, while 2 is 2 6. Then if you go put into the formula, and then you can get you get this gradient -6. Same way, you just find C and find the error equation. Then you have to substitute the values into this main formula, and you'll get this equation, -11.t plus 61.22. Since you're finding 2 and 3, you just substitute into the equation, and you'll get 38.42% for 2 seconds and 27.02% for 3 seconds. Well, you just have to repeat the entire process, just increasing in range. Now 3, 4, for 3 and 4 seconds, you can see that we found 31.01% for 3 seconds, 25.31% for 4 seconds. You just have to do the same process, just repeat the entire process again and again until you go to 8. Since now it's 4, 5, then 6, 5, 6, 6, 7, 7, 8. Then last is 8. The reason we're doing it till 8 is because when you reach 8, it reaches it shows no error. We have to only find until where it has error. So it's 8, 9 and 10 is going to be the same value. So now then we can see that it's 35%, like just now. Without any error, it's 35%. So now you can see that now this is the value we found. We just we tabulate the entire answer, and from all these answers we just make it into a table and then make it into a graph. So this is the graph. Next is PID. PID is almost similar to PD, just that he has some additional stuff, which is KD equal to 0.7. No, KI equal to 1.1. Now what's the difference? That this is the main equation. Just substitute all the values, and you'll get this equation, and substitute 0 seconds, 1 second, and 2 seconds, and you'll get this answer: 38.99% for 0 seconds, 62.93 for 2 seconds, and 1 second you can get 47.83 seconds. Percent. You repeat the process, but you just repeat the process until the end. But there's extra stuff which is here. You have to find P2 before the previous P. So now P2, the EP you use in this equation here is from the previous one. Like here is, you can see that the EP is 3T, so we have to substitute into here 3T. Then you'll find this 47.554%. Then put into the main equation. The difference about this main equation is that the n is P2. So in increase you got P3, P4, P5. Then you'll find that this is the percentage you found for 2 and 3. Same way, Px, which is the previous one, is 47.54. If you go up here, you can see 47.54 here. So, and the EP is also from just now, which is negative 60 plus 18. Yeah, so negative 18. Repeat the process, you can get the percentage for 3 and 4, 5, 4, 5, and you just repeat the entire process again and again until you go to 7 and 8. Now, when you go to 8, since the formula has changed, even though the formula has changed from PD, the values for P8 and 9 and 10 will be the same, like here, because of this. There's no error, so it will be the same value. So now here is 51.72. So at 8, 9 seconds is the same percentage, and then we tabulate the findings, and then we just make it into a graph. Yep, and that's all from me. Thank you very much.